Usually when we think about the rules of the physical world,
Right.
we expect, a certain obedience. Like you drop a glass on a tile floor, it shatters.
Right, yeah.
You throw a ball against a wall, it bounces back. It's comforting. We really rely on cause and effect. We like things to be predictable, to just follow the basic rules of common sense that we all learned on the playground.
Absolutely. The whole Newtonian clockwork universe thing.
Exactly. But step into the quantum world, and that glass doesn't just shatter. It behaves as if it passes through the floor, reassembles itself, and then basically questions whether the floor ever existed in the first place.
Yeah, it completely breaks the rules.
It really does. So welcome. Today, we're bringing you a custom-tailored deep dive into one specific, honestly mind-bending topic, the double slit experiment. Our mission today is to extract the vital nuggets from our sources without, getting bogged down in dense math or heavy jargon.
Which is easy to do with quantum physics.
Oh, so easy. But I promise you, by the end of this, you're going to understand exactly how a simple setup, literally just 2 holes in a screen, forced the greatest minds in history to just completely rethink the nature of reality.
Yet we're going to look really closely at how a very basic observation just dismantled that predictable worldview. The universe was considered this giant clockwork machine, action and reaction. But this one experiment proved that at a fundamental level, nature operates on rules that seem, well, entirely counterintuitive.
Okay, let's unpack this, because before we can understand how this experiment broke reality, we first need to establish what normal reality looks like.
Right. The baseline.
Exactly. The physical setup for this experiment is almost laughably simple. Imagine a solid wall. In the middle of this wall, there are 2 narrow vertical openings, 2 slits, right next to each other. And just behind that wall, there's a second surface.
Like a blank screen.
Yeah, a blank screen acting as a canvas to catch whatever we throw through the slits.
So, to ground this in everyday mechanics, our sources have this great analogy. Imagine standing in front of that wall with a bucket of tennis balls.
Tennis balls? Okay.
Yeah, and we can dip them in, like neon paint, to make the impacts really visible.
Yeah.
You start throwing these paint-dipped tennis balls at the wall.
And I'm assuming most of them just hit the solid part of the wall and bounce right back.
Exactly. But because your aim has natural variation, eventually a ball will pass cleanly through the left slit, and it leaves a bright neon mark on the screen behind it.
Right.
And then another ball will happen to pass through the right slit, leaving a mark over there.
So if you throw, say, 1,000 tennis balls, you end up looking at 2 distinct, totally separate clusters of neon paint marks on the back screen. One cluster directly behind the left slit, one behind the right.
Spot on. Particles, like tennis balls, they behave like solid objects. They travel in a line, they go through one hole or the other, and they hit the target.
Yeah.
There's zero ambiguity.
Okay, perfectly logical.
But this is a physics experiment. So scientists swapped out the tennis balls for light. They shined a steady beam of light at the wall with the 2 slits.
Now wait, if light is made of tiny solid little particles, which, fun fact, was actually Isaac Newton's dominant theory for a long time, you'd expect the exact same result, right?
Would. You'd expect to see 2 bright bands of light on the back screen, perfectly aligned with the 2 slits.
But they didn't.
No, they didn't. Instead, they saw this pattern of alternating bright and dark stripes spread out all across the entire back screen.
Just everywhere.
Yeah. A bright stripe, a dark gap, a bright stripe, a dark gap. In physics, this is known as an interference pattern.
Which completely ruins the idea of light acting like tennis balls. The sources give a really clear analogy for this too: ripples on a still pond.
I love the pond analogy. Think about dropping 2 pebbles into a quiet pond at the exact same time. They both create these expanding rings of ripples that travel outward. When those 2 sets of expanding ripples meet, they physically interact. If the peak of a wave from the first pebble meets the peak of a wave from the second pebble, they add together. They push the water even higher, creating this super peak.
And on our screen, that super peak translates to one of those bright stripes of light.
Exactly. And the reverse is also true. If the peak of one wave meets the deep valley of another, they cancel each other out. The upward push and the downward pull just balance out, and the water goes flat.
Ah, and on the screen, that flat water is the dark gap where no light appears.
You got it. So light behaves like a continuous flowing wave. The single beam hits the wall, passes through both slits simultaneously, splits into 2 new waves, and then they fan out, overlap, interfere with each other, and create the stripes.
Wait, so far this is surprising, but it's completely understandable. Like, okay, light is a wave, tennis balls are particles. Makes sense. Where does the spooky quantum physics actually enter the story?
Well, the mechanics of waves are elegant, sure. But scientists wanted to push the boundaries. They wanted to find the exact point where light stops being this continuous wave and starts acting like individual, indivisible pieces.
Fundamental building blocks, right, photons.
Right, photons. So here is the crucial next step. They fired light through the slits, exactly one photon at a time.
Here's where it gets really interesting.
Oh, it does. They developed tech to turn the intensity of the light source down so incredibly low, it was just spitting out a single photon, one solitary packet of energy.
But wait, if you're only firing one at a time, there's no continuous wave for it to crash into. The interference pattern should be physically impossible.
Logically, yes. If you fire one particle, there's nothing for it to overlap with. You're basically back to throwing a single tiny tennis ball. It has to travel to the wall, pass through either the left or the right slit, and hit the screen.
So you set up a sensitive screen, you fire one photon, and ping. A single dot appears.
Yep. You wait. You fire other one, ping, another single dot. After the first dozen hits, it just looks like a random scattering of dots.
Just static, basically.
Exactly. But you keep the emitter running. One particle, long pause, then another. Hours go by. Thousands of solitary particles are fired, completely isolated from each other.
Yeah.
And when you step back and look at the final accumulation of all those individual dots, they have grouped together to form the exact same wave pattern of alternating bright and dark stripes.
Oh, wow. That implies that a single indivisible photon is somehow interfering with itself.
Which is insane.
It is. How can a solid particle do that? Doesn't make any sense to say a single object is going through both slits, interfering with its own trajectory, and landing on a designated spot.
It doesn't make sense classically, no. We have to completely discard our understanding of solid objects. To grasp this, you have to stop thinking of the photon as a tiny, hard tennis ball. You have to start thinking of it as a wave of probability.
Okay, a wave of probability. The Physicians used a rumor analogy for this, right?
Yeah, think of a rumor spreading through a crowded city. It doesn't travel in a single straight line like a car. It diffuses. It takes multiple paths, moving through different neighborhoods all at once. The rumor exists in this state of overlapping possibilities across the whole city.
Right, but the moment a journalist finally verifies it and prints it in the newspaper, all those spreading possibilities instantly collapse into a single concrete fact in one specific location.
Exactly. The photon is the rumor. Before it hits the screen, it isn't a solid object occupying one specific space. It's a wave of potential locations.
So that wave of probability passes through both slits at the same time, interferes with itself like the ripples in the pond, and dictates the mathematical likelihood of where it will eventually land.
Yes, and when it finally hits the screen, when the rumor is printed, the probability wave collapses and it materializes as a single physical dot.
I mean, I would assume scientists just thought their equipment was broken.
Oh, they totally did. They'd assumed it was a fluke. But they repeated the experiment thousands of times. They didn't just use photons either. They fired electrons, then entire atoms.
Wow.
They even scaled up to massive molecules containing dozens of atoms. Every single time, firing them one by one, the isolated particles built up an interference pattern.
That is wild.
Richard Feynman actually stated that this single experiment contains the, quote, central mystery of quantum mechanics. It's this profound moment of reality teaching us humility. The universe basically whispering, you do not yet understand me.
But human curiosity doesn't just accept a mystery like that without, trying to peek behind the curtain. If a particle is being fired and it physically has to go somewhere to reach the screen, scientists naturally wanted to catch it in the act.
Of course they did.
They had to try and outsmart the probability wave to see exactly which slit the photon was passing through.
Right, and the methodology makes perfect sense. They just placed a tiny, highly sensitive detector right next to the left slit and another one next to the right slit.
Just to watch them.
Just to watch. Record the physical path.
Okay, so they turn on the detectors, fire the solitary particles, and it works, right? The detectors register left, right, left, left, right. They successfully caught the particles going through one slit or the other. They forced the photons to act like solid, measurable chunks of reality.
They did. But when they look at the final accumulation of dots on the back screen, the interference pattern had completely vanished.
Completely.
Gone. Instead of the wave stripes, the screen just showed two basic, bright clusters of hits. The exact same pattern you get from throwing the tennis balls.
Wait. The moment they tried to detect the particles stopped behaving like a wave. They just reverted to ordinary matter.
Yes. The very act of measuring them changed their fundamental behavior.
Does this mean human consciousness literally changes physical reality just by looking at it? Like, does the universe know a human mind is paying attention and it hides the weird quantum stuff?
What's fascinating here is how widespread that specific misunderstanding is. It is heavily popularized in, like, sci-fi and pop culture.
Right. Guilty as charged.
People hear terms like observe or watch, and they automatically map human consciousness onto those words. They imagine reality as like a video game engine that only renders the complex graphics when the player's camera is pointed at it.
Right.
We need to completely dismantle that idea. In quantum physics, a measurement absolutely does not require a human mind. It doesn't require a conscious entity at all.
So what exactly is a measurement then, if not someone looking?
It's a physical interaction. Think about being blindfolded in a pitch-black room, and you want to figure out the exact location of a swinging pendulum.
Okay.
You have no light. The only way to find it is to stick your hand out until the heavy metal weight physically hits your fingers.
Ouch, but sure.
Right. You found its location, but the very act of it hitting your hand absorbs its energy, changes its momentum, and permanently alters its path. You cannot gather the information without physically interacting with the system.
But couldn't we just, I don't know, build better, gentler detectors? Something that doesn't bump the photon so hard?
That is the crux of the dilemma. There is a fundamental mathematical limit to how gentle a measurement can be. You can't interact with the system using less than one quantum of energy.
One photon or one electron?
Exactly. At the scale of tennis balls, bouncing a single photon of light off the ball to see it doesn't affect its trajectory. But at the quantum scale, bouncing a photon off an electron to measure it is like hitting a billiard ball with another billiard ball. It's a violent collision.
Wow. Okay, so the act of gathering the data fundamentally alters the state of what's being measured.
Yes. The sheer act of placing a physical detector at the slit forces that spread out wave of probability to interact with the detector.
Which forces the rumor to become a fact prematurely.
Prematurely, exactly. It collapses the wave state at the slit rather than at the back screen, so the particle travels the rest of the way as a solid little tennis ball. You cannot separate the observer, meaning the physical measuring device, from the observed.
Okay, I want to make sure we highlight a really vital distinction from the sources here. The distinction between evidence and interpretation.
But very important.
Because the evidence, the double slit, the waves, the detectors, is absolutely real, repeated and verified for nearly a century.
Undeniable.
So what does this all mean? How did the scientific community process this reality-breaking information? I mean, we're talking about the absolute titans of physics here. Einstein, Bohr, Schrödinger.
And they could not agree.
Yeah.
They were looking at the exact same experimental data, the exact same dots on a screen, and walking away with completely conflicting views on the nature of existence.
That's crazy to me.
You had Albert Einstein on one side, and he was deeply unsettled by the idea of reality being based on probability. He famously said, God does not play dice with the universe.
Right. He believed the particle always had a definite location and path even before we measured it.
Yeah, he thought quantum mechanics was just an incomplete theory, that there were hidden gears in the clockwork we just couldn't see yet.
But Niels Bohr championed a totally different framework, right? The Copenhagen interpretation.
Yes. Bohr basically argued that the particle doesn't even exist in a solid physical state until the exact moment of measurement.
Meaning, asking where the photon is before you measure it is a fundamentally flawed question.
Right. He compared it to asking, what is the physical weight of jealousy? The property you're trying to measure just doesn't exist in that context. Bohr argued that position and momentum aren't inherent properties of a particle at all.
They're just the results of our interaction with the particle.
Exactly. The universe doesn't have a defined state until it's forced to interact with a macroscopic system.
It takes an enormous amount of intellectual courage for the most brilliant minds on Earth to look at a physical experiment, confirm the data is flawless, and just admit they cannot agree on the fundamental mechanics of reality. Our sources really emphasize the value of this honest uncertainty.
Yeah. If we connect this to the bigger picture, admitting we don't know is the most powerful engine for discovery. I mean, science doesn't progress by simply confirming what we already assume to be true.
Right. False certainty is a trap.
Exactly. Progress happens precisely when reality throws a wrench into our perfect, predictable models. When the data tells us a single particle can exist as a wave of probability, it forces us to reconsider the entire foundation of physics. Every great scientific revolution begins when someone is willing to look again, when they assume the obvious explanation is correct.
Which brings us back full circle. We began this deep dive by talking about a predictable world, cause and effect, dropping a glass, throwing tennis balls, and by shrinking our perspective down to a single photon of light passing through two tiny slits, we uncovered a universe that completely defies human intuition.
It really does.
We found a reality where objects exist as a spread-out field of possibilities, and where the physical act of measurement forces those possibilities to collapse into a single outcome. It is a brilliant reminder that no matter how much we learn, there is always room to be surprised.
Definitely. And as we conclude, I want to leave you with a final, lingering thought to mull over.
Oh, lay it on us.
Well, we've established that a single particle can behave as though it's in two places at once, right? And that the sheer act of measurement physically changes the outcome of reality.
Right.
But absolutely, all of human scientific inquiry relies on measurement. It relies on the construction of detectors. So if the physical act of asking a specific question dictates the physical state of the outcome,
Oh, I see where this is going.
then how much of what we confidently call reality is merely a reflection of the specific instruments we build?
Wow.
If humanity had evolved to ask entirely different questions, or if we had built fundamentally different methods of interacting with the quantum world, would we be observing and therefore inhabiting a completely different universe?
That's going to keep me up at night. Next time you drop a glass on the floor, just be glad it only shatters.
Seriously.
Thank you so much for joining us on this deep dive. Keep questioning the obvious and never stop exploring the strange mechanics of our reality.